Here are the answers to the physics study guide. We started with vocabulary. Speed is the rate at which an object moves, but velocity is speed in a given direction. Acceleration is the change in velocity over time, and there are 3 ways to accelerate. You can speed up, slow down, or change directions. The reference point is the object that appears to stay in place. So in the Ninja Cat video, we looked at the chair as a reference point. The Ninja Cat started before the chair, and we could tell he moved because at the end of the video, he was in front of the chair. Motion is when an object changes position over time when compared with a reference point. In order to calculate speed, we use the 4-step formula. We write down what we know, and in the first one, we know distance equals 200 meters and time equals 15 seconds. The second step is we write the formula we'll use. Speed equals distance divided by time. The third step, we'll plug into our numbers. 200 divided by 15, and we get a final answer of 13.3 meters per second. We follow the same steps in order to solve for speed in the next 2 and 3 problems. A position versus time graph is a position of an object over the time. Looking at this graph, the speed of the car is not constant. It was not in a straight line. The car is not moving from hours 3 to 4 because it's at a horizontal spot. That means he stayed in the same position. Looking at forces, the net force of the first one right there, they're both going in the same way, so 3 plus 2 is 5 newtons to the right. The next example, they're pulling in opposite directions, so they cancel each other out, so the net force is 0 newtons. Looking at the up and down, that object will go 6 newtons up. Looking at the car, 7 minus 10 gives us 3 newtons to the right. Looking at the tug-of-war, we'll go 100 newtons to the left. And looking at the car with the accelerator, it'll go 13 newtons to the right. Newton's first law means an object at rest will remain at rest and an object in motion will remain in motion at a constant speed and in a straight line until an unbalanced force acts on it. The second law says the acceleration of an object depends on the mass of the object and how much force is applied. The third law states when one object applies a force on the second object, that second object applies an equal and opposite force on the first. So looking at these examples, it is easier to throw a tennis ball than a bowling ball. That is Newton's second law. It's looking at the difference of masses between the tennis ball and the bowling ball. It requires less force to move the tennis ball than a bowling ball. 2. A person moves the paddle backwards and the boat moves forward. Due to equal and opposite forces, this is an example of Newton's third law. A water bottle sits on a desk. It'll stay at rest until a force acts on it. That's the first law. It takes more force to move a desk than a pencil. That has to do with the differences in masses, so that's the second law. Number 5, Manuel's bike is moving forward even though he has stopped pedaling. That's the law of inertia, or Newton's first law. When we look at applying these laws, if we're looking at the basketball player on the right, the first law is seen because the ball is at rest and will stay at rest until unless the player applies a force to the ball. Newton's second law says if the player applies more force, then the basketball will travel at a greater acceleration. You need to use the words that are used in Newton's second law. Newton's third law, the player exerts a force on the ball, and the ball exerts an equal and opposite force back on the player. Notice how I use the terminology from Newton's laws into the example. Looking at energy, give an example of potential energy. A person standing on top of a high cliff has a lot of potential energy. Potential energy has to do with the height of an object, and therefore that's an example of potential energy. An example of kinetic energy is when an object is moving. So that person who's jumping into the pool from the cliff, when he's moving, that potential energy has now turned into kinetic energy. Or just when a skateboarder is moving, that's kinetic energy too. Looking at the image below shows a graph rolling on a ramp from A to B. Which letter shows where the ball has the least kinetic energy? That's where it's going the slowest. So the least kinetic energy is where it's not moving, position A. Where does it have the least potential energy? When it has the lowest height. When it's in the lowest position, that's position D. Which letter shows when the ball has less potential energy than when at point B? So it's at point C. More vocabulary. Gravity is a force of attraction between two objects that's due to their masses and the distance between them. If we increase the mass of the objects or decrease the distance between the objects, our gravity will increase. Mass is a measure of the amount of matter in a given object. Weight is a measure of the gravitational force exerted on an object. And friction is a force that opposes motion. Looking at the difference between mass and weight, mass is the same on all planets. It's how much matter an object has. You don't gain more matter if you go to a different planet. However, your weight, because it's a force, it has to do with gravity. So your weight does change on different planets because there's a different amount of force because the size of the planets are different. So here on Earth, you'll have a greater gravitational force, a greater weight on Earth than on the Moon because the Moon is smaller, has less mass. There are three kinds of kinetic friction. There's rolling, sliding, and fluid friction. What two factors determine the strength of the gravitational force? That's mass and distance. 3 examples with gravity, anything with mass. So myself, a pencil, or an iPad. Something that does not have gravity would be an emotion, or something that does not have mass. Why does a feather and a hammer hit on the same time at the Moon, but on the Earth? All objects on Earth fall at the same rate, 9.8 meters per second on Earth. But we don't always see that because of fluid friction. On Earth, we have air, which causes friction and slows things down. On the Moon, there's no air, therefore those objects aren't affected by fluid friction and will hit the ground at the same time. Looking at the net force diagram of these examples, we've got an object going one way and friction acting against it. Friction always opposes the direction of the motion. That is it.